this lecture today. I am lecturer Zeynep Isa Jasm from Pharmaceutics Department, College of Pharmacy, University of Baghdad. I graduated from this college in 2008, and I have master's degree in pharmaceutics since 2014. Welcome again. The presentation is about freeze drying in pharmaceutics, principle and applications. First of all, the objective of this lecture is focusing on number one, what is the freeze drying, including definition and history? Number two, what is the principle of freeze drying? Number three, what are the types of freeze dryers? And finally, what are the applications and limitations? Freeze drying is the process by which the solvent, usually water and/or suspension medium, is crystallized at low temperature and removed by sublimation. So that sublimation is the most important process in the freeze drying. Sublimation is the direct transition of water from the solid state to the gaseous state without melting. That is mean without passing to the liquid phase. Lyophilization describes a process to produce a product that leaves the dry state. Although lyophilization and freeze drying are used interchangeably, freeze drying is more descriptive term. Freeze drying was invented by the Jacques Arsène d'Arsonval at the College of France in Paris in 1906. Later, during the World War II, it was widely used to preserve blood serum because the necessary requirement of a blood product at that era of time. Since then, freeze drying has become one of the most important processes for preservation of heat-sensitive biological materials. During the 1950s, industrial freeze drying of foods began. Freeze drying is currently used as a preservation method for foods, pharmaceuticals, and wide range of other products. This photo is belonged to the Jacques Arsène d'Arsonval, who invented the freeze drying, and he was the most important contributor in the emerging field of electrophysiology, which is the study of the effect of electricity on the biological membrane at the 19th century. To understand the principle of freeze drying, we should know the physical state of water. Water can exist in three phases: solid, liquid, and gas, as demonstrated by the phase diagram. Phase diagram of any substance, it is a phase diagram that describes the physical state of substance as a function of temperature and pressure. So here in the phase diagram of water, there is a plotting the pressure versus temperature. The pressure is range from 0 millimeter of mercury to beyond 1 atmosphere or 760 millimeter of mercury, while the temperature is range from below 0 degrees centigrade to above 100 degrees centigrade. The three lines describe the three phases of water: solid, liquid, and gas. When the pressure at 1 atmosphere and the temperature at 0 degrees centigrade, the water will undergo phase transition from the liquid phase to the solid state as the ice. This process is called a freezing process. At the same condition, melting of the ice can occur. That is mean these processes are coexist at equilibrium at this condition. Again, when the pressure at 1 atmosphere, but the temperature at 100 degrees centigrade, the water will undergo phase transition from the liquid state to the gaseous state as a vapor. This process is called vaporization. At the same condition, condensation of the vapor to the liquid state can occur. That is mean these two processes coexist at equilibrium. When the pressure at 4.58 millimeter of mercury or torr and the temperature at 0.0098 degrees centigrade, the water phase is solid, liquid, gas coexist at equilibrium. This point is called the triple point. That is mean it is the pressure and temperature at which the water phases, solid, liquid, gas coexist at equilibrium. So when does sublimation occur? Sublimation process occur when the pressure is reduced below the triple point. That is mean below 4.58 millimeter of mercury with an increase in temperature. Sublimation is the phase transition of water from the solid state after freezing to the gaseous state as a vapor without passing to the liquid phase. Why? Because the liquid phase doesn't exist at this condition. At the same condition, deposition, which is the reverse phase of sublimation, from the gaseous state to the solid state occur. That is, mean these two processes coexist at equilibrium, but below the triple point, below 4.58 millimeter of mercury of the pressure. There is another point in the phase diagram of water, which is called the critical point. As you can see in this following figure, when the pressure is above the critical point, the water doesn't exist neither as a liquid or as a gas, but exists as a fluid that is called supercritical fluid, which can be used in the extraction process. Again, the principle of freeze drying is depend mainly on the sublimation process. As I said, the sublimation process occurs when the pressure reduces below the triple point, that is mean below 4.58 millimeter of mercury with increase in temperature. This is the principle of freeze drying. Typical units used to measure vacuum pressure can be demonstrated in this table, in which one torr it is equal to 1 millimeter of mercury, that is represent 1,000 micron, and it is equal to 133.3 Pascal, which represent 1.3 millibar. These units used mainly to measure vacuum pressure. Freeze drying stages, there are 4 main stages for freeze drying. These are, number one, freezing. Freezing of the product is actually the most critical part of a freeze drying process, which can occur or can be done either by freezing the product, freezing the sample in a special freezer or refrigerator, or by cooling the shelf temperature in the cooling system of the freeze dryer. Freezing process is very important in order to separate the water from the sample as ice crystal to enable its removal or drying in the second stage. Second stage of freeze drying is called the primary drying, in which depend on the sublimation process. As I said, sublimation process require reduction in the pressure below the triple point with increase in temperature in order to remove large quantities of water from the sample to keep low level of water inside the sample. The third stage, that is called secondary drying or called desorption step in freeze drying. This process is very important. In this process, the excess moisture present in the sample can be removed by this process. That is, mean the water that is difficult to be removed in the primary drying, it can be removed here in this stage. After getting the final product, the freeze-dried product, cupping and sealing is very important, which is the fourth stage of drying, in order to protect the freeze-dried product from
أستاذ الحضور نعتذر عن هذا القطع خلل بالإنترنت يم زينب، إن شاء الله صدقاء ونكمل المحاضرة.
أعتذر عن هذا الانقطاع. حعيد الفريز دراينج ستيجز. Freeze drying stages. There are 4 main stages for freeze drying. These are: number 1, freezing. The freezing of the product or freezing of the sample is actually the most critical part of the freeze drying process. This can be done either by cooling the sample in a special freezer or by cooling the shelf temperature of the cooling system in the freeze dryer. Freezing process is very important in order to separate the water from the sample as ice crystal to enable its drying in the second stage. The second stage of the freeze drying is the primary drying, which is depend on the sublimation process. As I said, sublimation process depend on the reduction of the pressure below the triple point. That is mean phase transition of water from the solid state as ice crystal to the gaseous state as a vapor without passing to the liquid phase. In the primary drying, large quantities of water can be removed from the sample in order to keep low level of water inside the sample. That can be removed again in the third stage. The third stage of freeze drying, which is the secondary drying or called desorption step in freeze drying. This step is very important in the freeze drying process. This step is also require further reduction in the pressure below the triple point in order to remove the excess moisture present in the sample. In this process, the water that is difficult to be removed in the primary drying, it can be removed here in this third stage. Then after getting the final product, which is the freeze-dried product, the cupping and sealing is very important, which is the fourth stage of the freeze drying in order to protect the product due to the hygroscopic nature of the freeze drying product. In this video, I want you to see the freeze drying stages. So enjoy seeing this video.
Pharmaceuticals dedicated lyophilization facility. Freezing the product. Converting solution in the form of ice. Primary drying. Sublimation of ice directly into water vapors. Secondary drying. Eliminating the final traces of water. Stopping and capping the lyophilized product. Symbol of quality.
So from the previous video, we can summarize the stages of freeze drying. The first one, which is the freezing the product, it requires the following condition in which the pressure is equal to 1000 millibar, which is equal to 1 atmosphere. And the temperature below 0 degrees centigrade, that is minus 60 degrees centigrade. These requirements for the freezing the product. In the second stage, the primary drying requires further reduction in the pressure below the triple point, so that the pressure here is at 1 to 0.1 millibar, and the temperature at 5 degrees centigrade. This process in order to remove large quantities of water from the sample and depend on the sublimation process. In the third stage, which is the secondary drying, require further reduction in the pressure at 0.03 millibar and the temperature at 20 degrees centigrade. This process, as I said, it is required to remove the excess moisture present in the sample. These are the main stages of a freeze drying process. In order to understand the time required for freeze drying, in this figure, there is a plotting shelf temperature in degrees centigrade versus the time in hour. In the first stage, which is the freezing or solidification of water as ice crystal, it requires reduction in temperature below 0 degrees centigrade. The time required for this process is approximately 10 hours to keep the level of water at percent range from 95 to 90%. In the second stage, which is the primary drying or called ice sublimation process, it requires an increase in temperature and the reduction in the pressure. And the time required for this stage is approximately 30 hours after solidification to keep the level of water at a percent range from 5 to 10%. While the third stage, which is the secondary drying or called desorption step, it requires a slight increase in temperature, and the time required for this process to eliminate or to dry the excess moisture of water in the sample is approximately 10 hours after primary drying to keep the level of water at a percent range from 1 to 2%. So that the overall time required for freeze drying is approximately 50 hours or longer, depending on the sample characteristic and depend on the type of freeze dryer. So what are the types of freeze dryers? There are 3 methods can be used to freeze in the freeze drying process. These are number 1, benchtop manifold freeze dryer, which is most commonly used in laboratory, and I'll discuss it later. The second method, which is the batch method. In this method, large numbers of similar size container-like product are placed together in a tray, like a tray dryers. The main disadvantage of this method is the difference in the heat input between the front and the back of the freeze dryer. This difference results in the difference in the drying rate and difference in the moisture content in the final product. This method is suitable for freeze drying proteins and biotechnology materials. The third method, which is the bulk method, this method is suitable to freeze drying large quantities of pharmaceuticals and foods in large scale, especially for materials that is not sensitive to atmospheric humidity. In the top bench manifold freeze dryer, it consists from these parts. The first one, which is the control system in which the temperature and the pressures are controlled in order to drive the sublimation process. There is also the condenser in case in the cabinet. Condenser is act as a refrigerator surface, which is required to drive the sublimation process and to catch or condense the gases that liberate from the sublimation process, and to prevent their passage to the vacuum pump and prevent the damage that may occur on the vacuum pump or other parts in the freeze dryer. Vacuum pump is a very important part of the freeze dryer, which are required to provide the environment required for freeze drying to drive the sublimation process, to provide the pressure required for the process. On the top, there is a product addition station, which is the manifold with valves. This is a close picture for the manifold with valves in which different flaskware of different size, ampoules, vials can be attached directly to the manifold with the help of the valves. Manifold freeze dryer is the best method to be selected in the laboratory due to many reasons. These are, number 1, number of users in the lab is usually high and the amount of the product they are making is small. Number 2, large numbers of small individual samples. Number 3, freeze-dried product not for commercial use at this stage. And number 4, very early stage research. For these reasons, the selection of manifold freeze dryer is considered the best one. As I said before, the time required for freeze drying is approximately 50 hours or longer, depending on the sample characteristic and the type of a freeze dryer. So there are simple steps can be taken to reduce the required time to freeze the dry samples. These are, number 1, choose a freeze dryer that allows heat to be added to the sample. The most common accessories that provide heat to samples when freeze drying are heated product shells. Many end users do not realize that when freeze drying with a flask and manifold, heat still enters the samples. The heat source is essentially the room temperature that is usually around 20 to 25 degrees centigrade. That is mean room temperature is, play an important role in the freeze drying by applying or by providing as a heat source to enable the removal of water from the flux that is attached directly to the manifold freeze dryer. As you can see in this figure, ambient room temperature provides heat to encourage removal of water vapor from frozen samples when manifold drying. But you should keep in your mind that the room temperature should not exceed 25 degrees centigrade. Otherwise, the melting of the sample will occur. That is mean refreezing of the sample and require further time for a freeze drying process. So that the room temperature is very important, but should be at 25 degrees centigrade. Second point, you should know the eutectic point of your sample. Eutectic point or eutectic temperature of the sample, that is mean it is the temperature at which all the area of concentrated solute should be at a frozen state. That is mean the sample only exists in the solid phase. If your frozen sample goes to a temperature higher than the eutectic temperature, it will begin to melt. That is mean the sample should be cooled at a temperature slightly lower than the eutectic temperature. If the sample goes to a temperature higher than the eutectic temperature, it will begin to melt. So that you should know the eutectic point or the eutectic temperature of your sample. Third point, in this section, it deals with how to increase the surface area of your sample. Spreading the sample out to increase the surface area as well as forming a thin layer of ice will speed the sublimation process. So how can I get or how can I increase the surface area of my sample? There are commercial shell freezers. These are available to freeze samples in a flask. By increasing the surface area, more sample is in contact with the flask, resulting in a better heat transfer to the sample. As you can see in this figure, this is one of the shell freezers that provide or can, in which a thin layer of the sample around the wall of the flask can be obtained. This thin layer increases the surface area of the sample so that speed the sublimation process. So that the three steps can be used to speed the freeze drying process or reduce the time required for freezing is by choosing a freeze dryer that at heat source such as room temperature. You should know the eutectic temperature of your sample and increase the surface area of the sample. What are the factors that affecting on the freeze drying? There are many factors affecting on freeze drying. These are, number one, sample size. The size of the flask should be 2 to 3 times more than the sample size. Why? Because the increase in the viscosity or the thickness of the sample during the freeze drying. So that in order to enable the removal of water from the sample, the size of the flask should be 2 to 3 times more than the sample size. Surface area, as the surface area increase, it will cause speed the sublimation process, and you can increase the surface area by using shell freezers that provide a thin layer of the sample around the wall of the flask. Thickness or the viscosity of the sample, as the sample is very viscous, the removal of water or the drying of water from the sample will be difficult, so that dilution of the sample should be done. Eutectic temperature is also very important. That you should know the eutectic temperature of the sample. If the sample goes a temperature above the eutectic temperature of the sample, it will cause melting of the sample. Room temperature is also effect on the freeze drying process, and it should be kept at 25 degrees centigrade. Above this temperature, it will cause melting of the sample. That is mean require refreezing and require further time required for freeze drying. Freezing rate is also affecting on the freeze drying. If the freezing rate was very fast, it will form a small icy crystal of water that cannot be or difficult to be removed by the sublimation process. And the final product will look like a cake product that is mean contain large quantities of water. While if the freezing rate was very slow, that is mean it will form large ice crystal of water that can be removed by the sublimation process and leaving a porous structure inside the material and ensure conversion of the material from the crystalline to the amorphous form. You can see in this figure, these are two vials containing a final product after a freeze-drying process in the batch method. And the first one from the left, denoted by the letter A, it contained the freeze-dried product, while from the right, denoted by the letter B, it contained a cake-like product due to the reasons I mentioned previously. When you deal with the freeze dryer, especially the manifold freeze dryer, there are some considerations you should be kept in your mind. How do you know when freeze drying is done? This is number one. Number two, what about solvents other than water? Number three, monitoring vacuum pump oil is critical. So how do you know that the freeze drying is done or completed? There are three signs you can depend on them to know that the freeze drying is done. The first one, the amount of the condensate on the wall of the flask is reduced and disappear gradually. Number two, the temperature, and number three, the pressure. The temperature and the pressure goes back down to its maximum low as the system is dry and empty. These three signs, you should depend on them to know that the freeze drying is done. The amount of condensate, the temperature, and the pressure reduced to the minimum low level. What about solvents other than water? Most freeze dryers are working with water. So what about the use of organic solvent? The use of organic solvents require more attention in the freeze drying process because these organic solvents are characterized by lower freezing point. Lower temperature are required to freeze and condense solvents, and they can easily bypass the condenser and are causing damage to the vacuum pump. Freeze-dry refrigeration designs are available to provide the lower shelf and condenser temperatures needed to freeze and then condense some organic solvents. From this table, you can see the triple point of water 0 degrees centigrade in comparison with the triple point of other organic solvents. These organic solvents characterized by lower freezing temperature, so that require refrigeration designs in order to provide the lower temperature to freeze and condense these organic solvents that may cause damage to the vacuum pump or may cause damage to other part of the freeze dryer. In this table, you can see different type of solvent from acetic acid to the trifluoroacetic acid with different concentration from below 5% to 100%. And three colors, red colors, yellow color, and green color. The red color is that is mean or represent that this solvent, this organic solvent, cannot be removed, cannot be dried in the freeze dryer as the concentration demonstrated by this color. Why? Due to the melting of this solvent and melting of other constituents inside the sample. While the yellow color, for example, for acetic acid, the yellow color are 10% and 5% concentration. It means it can be removed or can be dried in the freeze dryer, but it may melt the organic solvent, but the other constituents inside the sample remain intact. But the best method to remove this organic solvent is the rotary evaporator. The green color, as in dimethyl sulfoxide, that is mean a different concentration or all the concentration demonstrated in this table, it can be working or it can be worked or can be removed or dried in the freeze dryer. In acetonitrate, there are three colors. The red one in 100%, it means it cannot be removed, cannot be dried in the freeze dryer. In the yellow color at 50%, it can be dried by the freeze dryer, but the best method to be selected is the rotary evaporator. While the other concentration, it can be removed or dried by the freeze dryer. so that safety consideration must be made when handling volatile and or potentially harmful materials. There are special filter cartridges or liquid nitrogen trap may be added to the freezer dryer in order to catch or condense certain solvents. As you can see in this figure, liquid nitrogen trap or filter cartridge can be added to the freezer dryer in order to catch or condense certain solvents that are characterized by very low freezing temperatures. Monitoring vacuum palm oil is critical. The vacuum palm oil are almost clear. The color of the oil should be similar to the color of vegetable oil. If it is turned milky, white appearance, or dark, that is mean or indicate it is contaminated with water. So that the oil should be drained and the pump should be refilled with a fresh charge of oil as per the vacuum pump manufacturer's instruction. Now, the second part of the lecture, which is the applications of freeze drying. The main reason why the products are frozen in pharmaceutical manufacturing is to protect sensitive substances from being contaminated by external factors like light, oxygen, or temperature changes. Commonly freeze-dried products include antibiotics, bacteria, vaccines, protein-containing product, cells, tissue, and chemicals. Without a freeze-drying technology, many life-saving drugs would not be available on pharmaceutical market. So that a freeze-drying process can be used to prepare different types of pharmaceuticals, such as hormones, proteins, antibiotics, and preservation of antibacteria, and preservation of the blood product, or in the manufacturing of certain enzymes to treat certain disease. Also, in the formulation of vaccine in COVID-19 pandemic, many pharmaceutical companies such as Pfizer and Moderna tried to formulate a vaccine in liquid formula. These vaccines contain active ingredient, messenger ribonucleic acid, carrier stabilizers, and the main volume or the main constituents inside the vaccine is water. These vaccines require ultra-low temperature as a cooling system in order to preserve or to maintain the stability of these vaccines. Recently, American and Russian pharmaceutical companies try or focus on the formation of the freeze-dried vaccine to treat coronavirus. Why? In order to eliminate the need for the ultra-low temperature as a cooling system during transportation of vaccine. But I think when they try to form a freeze-dried vaccine for coronavirus, it may become more expensive due to the need for the large numbers of freeze-drying or for freeze dryers, and in order to prepare large numbers of doses required to save large number of population. Application of freeze drying in pharmaceutical academic research, it can be used in the #1 development of nanoparticles and in the development of orally disintegrating tablets, and mainly used in the development of orally disintegrating films. In nanotechnology systems, especially for nanosuspension, nanoemulsion, solid lipid nanoparticles, in this system, the main drawback of this system is the Oswald ripening. That is mean agglomeration and aggregation of the nanoparticles during storage or during processing. In order to increase the stability of this system, a freeze drying of this system into to produce a freeze dried tablet that or a freeze dried powder that can be incorporated into oral dosage forms such as tablet or capsule. But in the freeze drying of nanoparticles, it may suffer from a disadvantage or a limitation, which is the aggregation of the nanoparticles, or may suffer from damage due to high viscosity. So that in order to reduce the interaction between these nanoparticles, a special excipient can be added, such as mannitol and the trihylose, which these called as cryoprotectant and lyoprotectant. This material can be added during formulation before addition of the nano suspension or any system of nanotechnology before addition to the freeze dryer. Lyophilization can cause also liposome fusion, so that cryoprotectant and lab protectant can be used also in the freeze drying of liposome in order to prevent the the rupture of the lipid bilayer. So that the addition of a cryoprotectant and lab protectant is very important in the preparation or in the freeze drying of nanoparticles. In the development of orally disintegrating tablets can be formulated by different methods. One of them is the freeze drying process, in which the drugs and excipient co-formulated in a drug solution or suspension, then dosed and poured into a blister pockets, then freeze drying to produce a freeze-dried tablet. As you can see in this blister that contain a freeze-dried tablet produced after freeze drying. The first technology that depends on the formation of a freeze-dried tablet or orally disintegrating tablet by freeze-drying process is the Zydis technology since 30 years ago. This technology was used to prepare different types of medication to treat different types of disease, such as schizophrenia and Parkinson. Under a scanning electron microscope, in this figure, there is a cross-section of Zydis tablet to provide a good insight into the highly porous structure. This porous structure is due to the sublimation process in the freeze drying process after removal of water. These pores enable the penetration of saliva inside the tablet so that the tablet rapidly disperses. This is the importance of a freeze drying in the formation of orally disintegrating tablet. Also, it can be used in the development of orally disintegrating film. Orally disintegrating or fast dissolving film can be prepared by the ordinary method, which is the solvent casting method, in which the drug dissolves in organic solvent or can be dispersed in the polymeric solution. Then, after pouring into a petri dish, can be then dried in oven at certain temperature. But freeze drying can be used also in the development of orally disintegrating film, especially for drugs or materials that is sensitive to heat. And these films is characterized by rapid disintegration in comparison with films prepared by the ordinary one. Now, limitations of freeze drying. The main disadvantages of freeze drying are caused due to its high energy consumption and high cost for both operation and maintenance. The energy required for freeze drying is almost double that required for conventional air drying. In addition, the cost of freeze drying is 4 to 8 times higher than conventional air drying. It is time consuming, and the fragility makes conventional packaging unsuitable for these products, so that it requires special packaging units for maintain during handling or during packaging or transportation. These are the main topics on freeze drying. Thank you for attendance and listening. If you have any question, just ask, and I'll try to answer you if I have the right one. And thanks a lot.
شكرا دكتورة زينب. السادة الحضور، أي سؤال عندكم دكتورة زينب جاهزة للإجابة، وأمامكم المايكات أيضا مفتوحة.
نعم، السلام عليكم.
عليكم السلام
دكتور خالد.
عليكم السلام دكتور.
عليكم السلام.
شكرا جزيلا طبعا الدكتورة زينب على المحاضرة القيمة، بالحقيقة يعني جدا ممتعة، غطت كل جوانب الفريز دراينج. يعني
شكرا
اكو
جزيلا.
معلومات بالحقيقة يعني صح مشتغلين فريز دراينج وجوز مدرسين فريز دراينج، لكن بهالتسلسل بهالوضوح يعني الدقة بالمعلومة، يعني فشي جدا ممتاز، ويعني فعلا محاضرة قيمة واستثمار جيد للوقت. أنا ما عندي بالحقيقة أسئلة، يعني أكثر مما هي تعقيبات بسيطة، يعني خصوصا موضوع السولفنتس.
نعم.
السولفنتس يعني المخطط اللي قدمتيه كان كلش حلو وواضح.
نعم.
كثير من احنا كان عندنا كلايوفيلايزر نشتغل عليه بالمختبر، احنا أكثر
نعم.
شغلنا كان بروتين، وهذه فأكويس مالتنا بالحقيقة السولفنت، لكن كانوا من الكيمياء، يعني طلاب الكيمياء يشتغلون باللافيلايزر لسه يعطلوا بسبب السولفنتس اللي يستخدموها. ما أتصور كانوا يستخدمون هذا التراب، النيتروجين تراب.
نعم دكتور، لذلك كان يتعمد ضفتها.
هاشتيدج يعني، ولو احنا ما أتصور يمكن احنا نستخدمه بالنانو، يعني بالفورميليشنز.
نعم
بالنانو بارتكلز راح نستخدم يجوز اورجانيك سولفنتس، فيجب نكون حذرين.
نعم صح.
بالحقيقة احنا ان شاء الله يعني في طور اصلاحه. احد اللايفلايزرز اللي عندنا الكبير هو راح فقط فاكيوم بامب، وقدمنا بها الاربعاء بالذات
نعم.
للصيانه، ويعني حيسوون كشف وان شاء الله يصلحوا.
نعم.
يا ريت يعني نكون انفولف
نعم.
يعني بالتشغيل مالته، يعني على الاقل ممكن نسوي تريننج بسيط ايضا
ان شاء الله
لطلبه
ان شاء الله.
الدراسات، لان جدا محتاج يعني دائما
نعم.
يوميا ما اشوفهم اذا ما يسالوني على الفلازر، فان شاء الله قريبا نصلح
ان شاء الله. بارك الله بجهودك دكتور، شكرا جزيلا.
بالعكس. وايضا عندنا الروم تمبرتشر جدا مهم، يعني كنت
نعم.
اشوف بعض السامبلات هي روم تمبرتشر 40 و50.
نعم.
هم بعض الطلاب يصورون هو عندهم يصير عندهم لايف، هو بالحقيقه يعني ما يصير لافيلايزيشن، يعني اكثر مما هو يصير ايفابوريشن.
نعم صحيح.
بالسامبل مالتهم. بعد يعني أريد أذكر هم يعني كيس حلوة كانت الرمديسيفير بالبداية من استخدموه بالكوفيد، الكومباشنت يوز وبعدين emergency يوز. كان اكو يعني تو دوزج فورمز بالحقيقة، السوليوشن فور اي في انفيوجن، وكان اكو لايفلايز باودر فور سوليوشن.
نعم.
فكان احنا اللي جانا العراق اجانا اللايفلايز باودر، العفو السوليوشن حتى استخدمناه بشكل شخصي.
نعم.
الانترستنج اللي كان الفرق بيناتهم هو اللايفلايز اتصور يعني اللي هو موست كومن حاليا، هو اكيد يعني اتصور مور ستيبل والشلف مالته لايف اطول. ما اعرف اذا مستخدمين بيها يعني كو سولفنت كميه اقل، فما اعرف اذا مر عليك هيك شيء رمديسيفير يعني باي اكسيدنت، او يعني ما راح تجيب حقيقه بالفورميليشن مالته.
نعم صحيح.
يعني knowing the difference بيناتهم. بس اتصور يمكن اللايف لايس كان يمكن it makes sense اللايف لايس powder should be يعني should have a longer shelf life.
صحيح. نعم.
على العموم شكرا جزيلا.
أنا أشكرك دكتور.
التوفيق إن شاء الله.
شكرا جزيلا. شكرا دكتور. أي أحد عنده سؤال ممكن يتفضل.